got it right there. I don't think I got it right. She's
Okay.
No, I don't think
All right, here we go. Number one, write the equation of the linear function. We're doing our little review here. Write the equation of the linear function where f of -1 is 7 and f of 4 is 2. So, what are we doing? We're finding the equation of a line. That's exactly right. And the 2 points that we have are -1, 7 and 4, 2. Remember function notation, guys? This is x. So when it says f of 4, x is 4. So what's the slope here? Chris said -1. I think he's right. Is he right? And then I'll pick a point. I'll use that one. So I got -x plus 6. I did that kind of fast though, so I could have a mistake somewhere. Is that what you got? And since the directions did specify a linear function, I'm writing my answer in function notation. That is not a big, huge deal, but we might as well follow the directions. Write the equation of the quadratic function in standard form. Let me make sure you understand what that is. Where f of 3 is 8. And the maximum is -511. Now, this is a quadratic. So if you find the slope, I'm not even reading on. I am just putting a big X through it, probably making some kind of comment like, ah! Because it's quadratic. What do I do? What do I know about this? Emma?
Maximum points are vertex.
Exactly. So whatever's happening, I know the vertex is -511.
Yeah.
So what can I do with that information?
You do vertex form.
Yep.
You have your x and y.
So I don't know what that is, but I know it'd be x plus 5 squared and plus 11. Would everybody agree with that? Now, there are billions of parabolas that have that maximum. We want the specific one that also goes through the point 3, 8. So 8 would be y. I don't know what that is. I'll call it n. 3 plus 5 squared plus 11. So I'll subtract 11. Please don't combine these numbers. They don't combine. I mean, you can combine these. So -3 equals 64n. Did you get -3 64s? Right? Do my arithmetic.
Okay, where's the 64?
What's 3 plus 5?
Oh, yeah.
Okay, now, we're used to writing our answer like this. Would you agree with that? I mean, that's the way we've been writing it. That is not standard form. That is the vertex form. Because this is the form where you can just look at it and say, okay, my vertex is at -511. Left 5 up there. By the way, does it make sense this is negative? Because that was a maximum, right? So it makes sense. Okay, standard form is what your calculator gives you. When you ask it to do quadratic regression, standard form is ax squared plus bx plus c. So we got to redo this equation so that it looks like that. Okay? So basically what that means is we just got to multiply all this out. So we got our f of x over here, our y's over here. -364 times x squared plus 10x plus 25 plus 11. Oh, so distributing is going to give me negative 3/64 x squared minus 30/64 x. I know that reduces, I'll catch it in a minute. Minus 75/64 plus 11. Negative 3/64 x squared minus, I'm going to reduce that, 15/32s. And then I'm going to use my trusty calculator. Negative 75/64 plus 11 equals math frac 629/64. So I just did let my calculator do all the work. Negative 75/64 plus 11, and then use my math frac button to bring it back to a fraction. Alrighty. Alright, now I got a bunch of points here. And we are going to use our calculator. To find the equation of the line that best fits the data and then describe the correlation. Okay, so first we're going to find the line. So what do? We go to stat edit and get rid of anything that's in there already. Did you get negative 2x plus 6.17?
Yeah.
And, okay, so first question says, find the equation of the line. Right there it is. Now, the second part says, describe the linear correlation. Okay? Now, my R value is negative 0.9997. Tell me about that.
So very, very strong
Negative correlation, that's right. So it's a very, I love it. She said very twice. Very, very strong negative correlation.
I have a question. It's like, the correlation is like 0.6 or something?
Weak.
Is that weak?
Weak.
No, no, okay.
So 0.7.
Weak positive.
When would it be considered strong? Like at 0.8?
Probably.
Okay.
Yeah. I don't know that there's a specific cutoff.
Did we get any
But-
like in between?
I don't know. If we don't, we just have to figure it out. You can do it, Emma. All right. Perfect. Next side. Here we go. Find the vertex and axis of symmetry. So this one already have the equation. We're going to find the vertex axis of symmetry. Now, I don't care how you do this, you've got a couple of options. Does anything pop into your head when I say find the vertex and axis of symmetry? That's what pops into my head too. X equals negative b over 2a. So this is actually going to be my axis of symmetry. So negative b over 2a. So my axis of symmetry is negative 2, if I did my work right. Now what does that mean about my vertex? Well, x is negative 2. And how do I find y? Plug it in. So I'm going to take 9 times 4, that's going to be 36, minus 72, minus 72. So that's 144 minus 36. I got negative 108. My goodness, did I do that right?
Yeah.
So that's my vertex. Okay. Last problem. Fisher, favorite student right here, right there, Fisher Van Root, figures out that for every 20% decrease in price, he will sell 10 more homework papers. He currently sells 200 papers at $5 each. How many will he sell if he optimizes the price? Now, from a business standpoint, what's Fisher trying to do? Make as much money as he can, right? And how is his income determined? The number he sells times the price each. So right now, Fisher's income is what? Right now, his income is 200 papers times $5 each. But what's he doing? He's making some changes. Every 20-cent decrease. So what's happening to this? $5 is going down in increments of 20 cents. And in the meantime, his sales are going up in increments of 10. If you FOILed all this out, which it is perfectly okay to do, if you FOILed it all out, and oh gosh, my arithmetic's going to be bad here probably. If we FOILed it all out, what kind of equation are we going to have? Quadratic. And the squared term is negative, which means the parabola opens down, which means the vertex is the maximum, and that's what he was trying to do, was find his maximum income, right? And that was his goal, to get the maximum income. So I have no idea. I'm hoping I multiplied this out right. If you multiply it out, then you can find the vertex the same way we did this one. So negative b over 2a, what is that, 2.5? Now what does that mean? $2.50, 2.5 papers, what is that, 2.5 whats?
2.5 price decrease.
2.5 price decreases. So if we have 2.5 price decreases, and each decrease is worth 20 cents, then 2.5 20s is 50. So he's gonna actually decrease his price 50 cents. So what is he gonna be charging? 450. The question said, how many will he sell if he optimizes the price? This is not the answer. This is his optimum price. How many will he sell? Well, remember he was selling 200 of them? And that was going up in increments of 10. So 2.5 tens would be 25, right? So he's gonna sell how many papers? 225 papers. Now, this problem, you can ask a lot of different questions. So one question would be, what's the optimum price? We figured that out. Another question is, how many papers will he sell? That's that answer. Another question could be, what is his maximum income? Well, that would be these two times each other, right? So all of those could be questions coming from the same problem.
Wait, the maximum is 450 times 35. The maximum is 450 times 35.
What do you think, Lucy? I think so.
I was doing stat, I think I messed up my calculator. It's like a graph is more.
I don't know.
But I'm gonna like reset.
Okay, you need to turn that water off. Okay. All right, so put that away, we gotta move on. So quiz tomorrow, I see you tomorrow, right? Quiz tomorrow, over 2.1 questions similar to those. Obviously, you gotta have a calculator. All right. Okay, so moving on, 2.2, here we go. Alright, so in this little definition here of a power function, any function that can be written in the form f of x equals k times x to the 8th. And we don't want anything to be 0. Okay, so I want you to think about your BFFs for a moment. There are some power functions in your BFFs. Is that a power function? Yes, because it's x to the first power. How about this one? Is this a power function? And this one is a power function. Now, some that you might not think of, these are kind of obvious, right? This is a power function because a square root is actually an exponent. What exponent is the square root, Corinne? 1/2. So this is x to the 1/2. How about this one? This is actually a power function because it's x to the negative first. And the behavior of power functions, the graphical behavior, depends on that exponent. So it's going to help you a lot because you already know what these look like, how they behave, and you know how these behave, and they behave differently. But keep that in mind when we get to a little bit later here, because that's going to be very, very helpful to you to keep all this straight. But number one, consider y equals the cube root of x. That is a power function. It is not one of your BFFs, but it is a power function. Do you know what it looks like? I'll give you a hint. It's the inverse of this one.
It'd be the other way.
So it would be not a squiggly down to up, but a squiggly left to right. Remember that you take these ordered pairs and switch them. So like this is the point 2 comma 8, 2, 8, that would become 8, 2. See how that works? And then this would be negative 2, negative 8, so it would be negative 8, negative 2, and so on. That's a picture of x to the 1/3 with x. What's its domain? We're doing a little function analysis here. Domain is negative infinity to infinity.
So is that like the logistic function, but it doesn't have like the
It has no asymptotes, and it can be negative. So,
like the same
sort of
shape,
similar,
but just
yeah. But this is going to go on forever and ever and ever. So we're going to talk about the same behavior. All right, what's the range of this guy? Yep, negative infinity to infinity. It's everything. It's everything. They're going up, 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 up. There are no asymptotes in this picture. There are no asymptotes in the picture. Were there any asymptotes in this one? Y equals x cubed? No. If the original didn't have asymptotes, the inverse isn't going to have asymptotes, right? All right, continuous? On its entire domain, that's exactly right. The whole thing, not lifting our pencil one time. Increasing or decreasing? Increasing on its entire domain.
Wouldn't it be like as x increases, y increases, but as x decreases?
Okay, I want you to stop me and listen very carefully, because I've said this before, I don't want to have to keep repeating it. When we talk about increasing and decreasing, we're talking about moving from left to right. Period. Okay? You're talking about something different. We're talking about in behavior. This is simply increasing or decreasing. As I go left to right, no matter where I start on this picture, I can start clear back here. As I go left to right, my pencil's only going up. Okay? Does it have any symmetry? Now, when I say that, I'm talking about our special symmetries. So is it symmetric about the x-axis? No. Y-axis? No. Identity line? No. How about the origin now? It is, because even just the couple of points that I plotted, this is the point 8 comma 2, and this is the point negative 8, negative 2. What happens when you have symmetry to the about the origin? You change both signs, and isn't that what happens on this picture? So it does have symmetry about the origin. This is an odd function. Odd function. Is it bounded? No. No. There is nothing containing it. It's going up, 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 up. It's going out faster than it's going up, but it's still going up forever. Does it have any extrema? No. No. Doesn't it? We're talking about no asymptotes. Now, Marin, we're talking about in behavior. So what happens to the function as I go to the right? As I go to the right on the picture, what is happening to my function? It's increasing forever and ever, so positive infinity. What happens as I go? Liam, are you awake? Yeah. Would you sit up, please? What happens as I go to the left on my picture? Okay, so the end behavior, Marin, specifically says go left. Okay? All right, next one. Y equals 1 over x squared. Now, let's try to graph this one without using our calculator. Let's see if you can logic this out. Any asymptotes? Any cannot be's? X can't be 0, and actually, y can't be 0 either. Think about that for a second, guys. If you put any number in here for x, will that fraction ever equal 0? Impossible, right? So we've got asymptotes, very much like we had with 1 over x. What's going to be different about this one, though? Actually, the shape is going to be very similar, but there's a big difference. What happens with 1 over x squared? Finley?
So could y not be negative?
It can't be negative. So, remember when we had with 1 over x, we had a piece of it here and a piece of it here? Well, guess what we're going to have now? We're going to have both pieces up here. Because no matter what you put in for x, if you put negatives in for x, y is still going to be positive. And isn't this going to be the image of this? I mean, aren't these going to be the same exact thing, just on opposite sides? Because positive 2 gives you the same answer as negative 2 does. So there's your picture, right there. Domain? Negative infinity to 0, and 0 to infinity, right? In other words, everything except 0. Range? Same thing. Oh wait, no, not same thing. What's your range? Just 0 to infinity. Yes, thank you. That's the domain. This is the range. Because there are no negative numbers in the range of this function. All the y's are positive. Continuous? Nope. It has a non-removable discontinuity at x equals 0. Or it has an infinite discontinuity, if you like that word better. Or it has a vertical asymptote at x equals 0. The picture is broken at x equals 0. Increasing or decreasing? Yeah, this is one of those that's both. Because the first piece of it is increasing. Would you agree with that? So from negative infinity to 0, our pencil is going up. But on the other side, from 0 to infinity, our pencil is going down. Symmetry? Y-axis, which makes this one even. Bounded below at y equals 0. This is bounded below at y equals 0. Remember, bounds are ceilings and floors. They go up and down. So we're bounded below at y equals 0. Extrema, asymptotes, already labeled them. Those are your asymptotes. And then end behavior. We want to know what happens as we go all the way to the right, and what happens as we go all the way to the left. All right, so what happens as we go that way? What happens to our curve? It's getting closer and closer to 0 from the top. That does not mean positive 0. That means 0 from the top side. What about when we go all the way to the left? Same thing. 0 from the top side. If you have an even function, doesn't it make sense that these would match? Think about that for a minute. Because what that says is, as you go that direction and this direction, the same thing's happening. Isn't that what happens in even functions, because they're symmetric about the y-axis? All right. Okay. A monomial. A monomial is a single term. Would you agree with that? All right, definition, I guess. Okay. Now, Now, number 2, match the equation to one of the curves labeled in the figure. So, we got 4 equations, A, B, C, D, E, or 6 equations, A, B, C, D, E, F, and we have to match them to one of the curves in the figure. Okay, now this is where your knowledge of those BFFs is really going to come in handy. I want you to think about x to the first, x to the second, and x to the third. I want you to think about their behavior in the first quadrant. Just think about just the first quadrant. What are all these doing in the first quadrant? Aren't they going up like this? Now, that one is straight up, it's a straight line. And these two are curves up. But that's the behavior of these. All right. Think about the behavior of this one in the first quadrant. Well, it only exists in the first quadrant. But what's it doing? It is not doing what these are doing. These are going like this, right? What's he doing? He's going out like that. Okay. And then think about this one, which is only in the first quadrant. What's he doing? He's coming down like that. There is a relationship between the size of the asymptote, the size of the exponent, and the way the curve behaves. So let's look at problem A. Problem A is an x to the 4th. It's going to behave exactly the same way these behave, except we put a negative out in front of it. So instead of going up like an x to the 4th would, it's going to go down. So A best matches letter G. Now, we're going to skip around a little bit. Let's look at C. Okay? C is an x to the 1/4. Which one of our BFFs do you think he's going to most closely square root? It's a square root problem. X to the 1/4 is a root, 4th root. So x to the 1/4 is going to approximate that. So that's going to have to be D. That's D. What about E?
Wait, which letters are we?
We're doing equation E right now. Equation E. And we're matching it to the picture above. So look at equation E. Look at its exponent.
It would be.
This was 1/2. This was 1/4. Isn't 2/3 kind of the same thing? Yes, because any exponent between 0 and 1 is going to approximate this behavior right here. If your exponent is between 0 and 1, it's going to look like this. So equation E is also graph D. Equation E and equation C have the same basic shape because they have a positive coefficient and an exponent between 0 and 1. And when you have a positive coefficient and an exponent between 0 and 1, you look like a square root function. Now, what do you think F approximates? F is going to approximate Which one? Equation F. Equation F. George? What? It would be A except for one thing. See the coefficient out in front of it, George? It's negative. So what is that negative going to do? Put you down in quadrant 4. So it isn't A, it is H. So a negative exponent puts you 1 over, automatically introduces some asymptotes. It will have this shape right here. A negative exponent is going to have this shape right here. If it happens to have a negative coefficient, then of course it's going to be upside down and it will have that shape right there. Okay, now that brings us to equation B. We haven't done equation B yet. Now, B has an exponent of 5/3. Our basic shapes are this, like our x squared and x cubed, our square root shape, and our reciprocal shape. Which one do you think equation B is going to match? Which of these general things is it going to match? Marin?
It would be the shape, the line B.
It's this one right here, except it's upside down, so it wouldn't be B, it would be G, because of the negative coefficient. Any exponent bigger than 1 is going to look like this, some variation of this. Even if it's a fraction, it doesn't matter. If it's bigger than 1, it's going to look like this. If it's less than 1, it's going to look like this. I'm talking about 0 to 1 positive, 0 to 1. It's going to look like this. And if it's negative, it's going to look like this. And then, of course, you got to pay attention to the coefficient. So, what do you think D, equation D, what do you think he's going to look like? He's going to look like the reciprocal, and he's positive, so that would be A. Okay? These are tied directly to your VFX. So if you can remember these general shapes, you're good to go. Now, tell me about C. What in the heck is graph C? Graph C. What's that? That's your line. That's this one, right? That's this one. Everything else is going to be a curve. The only way you're ever going to have a straight line is if you have a plane X to the first. Everything else will be some kind of curve. Got it? Okay. Number 3, direct variation and inverse variation. All right. I want you to think about this for a second. Make sure this is straight in your mind. I go to the store, I'm going to buy bananas. The more bananas I buy, the more money I have to pay. Would you agree with that? They charge per pound. So the more I buy, the more I pay. That's called direct variation. Because both things are moving in the same direction. As pounds go up, money goes up. If I buy fewer pounds, I pay less money. Direct variation. All right? I'm driving to school. If I drive to school at 30 miles an hour, it takes me a certain amount of time to get here. And then if I drive home at 40 miles an hour, it takes me less time. So in other words, as my speed goes up, the time it takes goes down. That's inverse variation. Okay? So that's the difference. Direct means we're moving the same way. Inverse means one's going up and the other one's going down. Okay. So we have general formulas for direct, inverse, and then a combination of the two, which is called joint. So let's see if we can do a couple of these problems. Write this statement as a power function equation. Use K for the constant variation. The area of an equilateral triangle varies directly as the square of the length of its sides. So direct variation fits this general formula. The area of the triangle, so I'll say A, this is A as my variable, varies directly as the square of the length of its sides. So Y varies directly as X. That's what the formula says. Y varies directly as X. So in our problem, area varies directly as the square of the sides. Right?
Why do we have K? Like, why is it?
Because the area isn't the side square. The area is some constant times the side square. I think it's root 3 over 4, something
It's
like
just
that.
like kind of our unknown
It's
constant.
a constant, yeah, it's a constant. Charles' law states the volume of an enclosed ideal gas at a constant pressure varies directly as the absolute temperature T. So volume varies directly as T. The current in an electrical circuit is inversely proportional, which is just another way of saying varies inversely, as the resistance R with a constant of variation V. So this time I'm not using K, I'm using V, and it varies inversely. So inverse is Y equals K over X. So for us, it's going to be I equals V over R, because they told me my constant is V. The volume of a circular cylinder with fixed height is proportional means varies directly. If it doesn't say inverse, it's direct. So is proportional means direct variation. So the volume for the fixed height is proportional to the square of its radius. The energy produced in a nuclear reaction is proportional to the mass M with the constant of variation being C squared. How many have ever heard E equals MC squared? Yeah.
What was there were like these, I don't know if anyone else remembers it, like these like dolls or something, they were like a knockoff like Barbies or Bratz, but they were like the E equals MC squared dolls.
Oh,
You know
for the
what
show.
was that? Project, that's who it was, but they were like dolls.
They were Project MC squared.
Good to know.
Bratz, Barbie dolls.
Like nerdy.
Nerdy. They were, remember that one that they had like lightning streaks in their hair? Brought back a lot of memories.
Thank you, Maureen, for sharing that. The speed of a falling object varies as the square root. Now, so again, all this different way of saying it. If it doesn't say inverse, then it's direct. Okay, so if it says is proportional, that's direct. If it says varies, it's direct, unless it uses the word inverse. So the speed speed varies directly as the square root of d, square root of the distance, with the constant of variation being the square root of 2g. Can these be combined? Can you multiply the square root of 2 times the square root of 3? Yeah, as long as these are the same root, guys, you can put them together. So P equals the square root of 2GD. All right, couple more and then we'll be done with 2-2. The volume, number four, the volume of an enclosed gas varies directly as the absolute temperature. Okay, I think we already did this. The volume varies directly as the absolute temperature. If the pressure of a 3.46 liter sample of neon gas, what would be the volume if the pressure doesn't change? Okay, so pressure is not part of this. What is the 3.46? Where does the 3.46 go in this? That's volume. And the temperature is 302. So can we find the constant or the K value for this particular example? There it is, right? I'm not going to type that in just yet. There, would you agree that's it? Then it says, what would the volume be if the temperature is now 338? So look at your equation. I want to know what the volume is. I know the temperature is 338. And now, don't I know that my K is this? So I'll just multiply that out. So 3.46 divided by 302 times 338. Did you get 3.872? And the unit on that would be liters? One more and then I'll shut up. The volume of an enclosed gas volume varies inversely as pressure. If the pressure of a 3.46 liter sample is 0.926, what would the volume be at a pressure of 1.452? Now notice they keep throwing in extra information. Does the temperature have anything to do with this problem? No, don't care about it. Doesn't change, it's the same for both, it's not part of our setup. So we can find K. And then, so 3.46 times 0.926. So there's my K value. And then divide that by 1.452. Did you get 2.207 liters? Is that right, or did I mess up? All right, 2.2 due on Friday. Today's Wednesday, right? Oh, we're the last period of the day on Friday. How wonderful. It's always everybody's favorite period of the week.